Yes, hello. This is going to be a recording over at least the first part of 11.1. 11.1 can take a little longer, so bear with me. It starts out pretty easy with the square root property, and that is if, and in the book they might use an A, but I'm going to go with this. If x squared equals k, what that means that if something squared equals a constant, then that something is the positive and the negative square root of that constant, meaning you're technically just taking the square root of both sides and then the x comes out, but then you have to consider that it has to be positive and negative as well. So you can just memorize that, or I can show you how it works every single time, but let's just do a few problems. So you would take, if you wanted, you could say x squared equals 343, and then you want to leave a little space here so you have room, and then you would say, oh, you could look at it like this, you know, take the square root, but you have to put the plus or minus, because there's going to be two things that make that statement true. So then x equals plus or minus square root of 343. 343. This one is 7 cubed, I guess. So if I'm correct, 7 times 7 times 7. So we need an exponent that matches our index. So 7 squared is 49. 49 times 7 is 343. And then you say what comes out, it's plus or minus, what comes out, the 7, and then the square root of 7, and that would be your answers. Or you could write it as x equals negative 7, square root of 7, one term, comma, positive, or just 7 square root of 7 in the answer box in MyMathLab. So it'll say, but you can put, it'll have a plus minus symbol that you can choose from the toolbox, or you just put them in separate and it'll say enter your answers, separate them with a comma. So on the second one, use the square root property to solve the equation. So same thing, you're going to take the square root, or that's something, you see how if you took a square root and then you have a square root of, let me show this again, but you really don't need to if you just accept. See, and here, if I use a different color again, you would take the square root, that would bring that x plus 6 out, and then whatever you do here, but you don't forget it, it's a plus and a minus. You should just memorize this little rule, and then you don't worry about showing that green part. Whoops. Okay, so x plus 6 equals plus or minus the square root of 4. So x plus 6 equals plus or minus 2. And then you have to understand this is two things. Students tend to really get confused here, but everybody agrees that the square root of 4 is 2. And then this is a plus or minus. So here, most of my students do a little bit better if I split this up and say x plus 6 is positive 2, or x plus 6 is negative 2. So you could split that up, you know, because you have those two options. If you split it right here, most people do a little bit better with that. So x equals, you would subtract 6 from both sides. And then x equals, and you would subtract 6. Negative 2, and then minus 6 is negative 8. So you should have two answers. This is a solution set, negative 8 comma negative 4. Do you see how it's not always plus or minus the same thing? You see how here, because this was already just something squared equals a constant. This here, this something squared is a binomial, so you're going to have to do just a little more work. Let me show you. Some people like it better to go from here. And then they say, well, I'm going to isolate the x. So x is negative 6. You see how you would subtract the 6. subtract the 6, but then people get a little more confused doing it this way. This is still two answers. So x is -6 plus 2, which is -4, or x is -6 minus 2, which is -8. Do you understand? Like, you can do this either way. Most of my students do better when we split it up from here to here. So personal preference, there's nothing wrong with either. Oh, I did want to show you how that one checked. So what do we have? Let's look at this real quick. Blah, blah, blah. We ended up having x is -8 and a -4. Let's check this. Now, why did I not necessarily check? When they start radical, the checking is absolutely mandatory, because if you don't check them, there could be an extraneous root. When they start out non-radical, checking is a good thing, but you can get away without it. But let's check it. Let's check the one in the original. So this is my original, and we're going to say x is -8. -8 plus 6, quantity squared, equals 4. And this is our check. We're asking, is that true? -8 plus 6 is -2. And a -2 quantity squared is a -2 times -2, which is a 4. And 4 equals 4, true. And then you can check the other one. I'll do it in brown. You know, we're going to check this one here. So the other check is if x is -4, -4 plus 6, quantity squared, equals 4, question mark. -4 plus 6 is +2, 2 squared equals 4, true. You see? So this is why you need that plus minus in that square root property rule. Okay, so let's just do a few more, and I'm going to make this one a pretty short one, and then we're going to do completing the square in another recording, because it just takes longer. This is still 11.1. 11.1 is a little bit long. So use the square root property to solve the equation. So let's work this one. And then they just get a little more involved. Do you see how you have something squared equals a constant? So something squared equals a constant. So, and that means that whatever that is plus or minus the square root of 12, because you're still using the if something squared equals a constant, and in this case, before I call it an x, you know, then x is plus or minus the square root of k. So same thing. So you just take that something. It's not always just an x. Sometimes it's a binomial, etc. It could be more than that. And then we would say, okay, 2x. And this is where you can debate, do you want to move that 7 over? And the 7 and the square root stuff doesn't combine, you know. So I'm going to go ahead and leave it. Lots of options. That's the problem always. Square root of 12, let's simplify. It's the same thing as square root of 2 squared times 3. 4 times 3 is 12. The 2 comes out, the 3 stays under. So 2 square root of 3. Then you could say, I'm going to split them right now. I'm going to say 2x plus 7 is negative 2 square root of 3, or 2x plus 7 is positive 2 square root of 3, and then isolate the x. And again, you can do this at different times. I just like this better. And I'm going to grab, hang on a minute. I did not give myself enough room. I need to move that out of the way here. So sorry about that. Okay, so 2x, this one, you know, this is that one, equals negative 7 minus 2 square root of 3, or 2x equals negative 7 plus 2 square root of 3. So just don't memorize thinking they're always opposites, exact opposites of each other. The final answer isn't always going to be. Now the 7 and the 2 square root of 3 aren't going to combine because they're not like terms. And now you have to isolate the x still. And then we're going to discuss what answers are allowed. Do you see how you need to divide by 2 and whatever you do here, or you need to do this whole side? The computer will take this as a final answer. If you have an imaginary number with it, you have to separate the real part and the imaginary part. But in this case, you don't have an imaginary part. So this should be okay as a final answer for one of them. And then this one here, oops, excuse me. We have a lot of options, so that can be a little bit difficult. Now you're going to take this side, you're going to divide by 2, and whatever you do here, you do here. So you have a -7 plus 2 square root of 3 all over 2. And again, the computer will take this. The computer will also take this as a final answer. I'm going to put it in a solution set. -7 plus or minus 2 square root of 3 all over 2. So that's those two answers all in one, and you have that option in the toolbox for plus minus sign. The one other thing that the computer will take is if you split up, but let's just go with this. The reason I'm showing this part now is you could split it. Each one of these is divided by the 2. We did this in chapter 5. If you take x is -7 over 2 minus 2 square root of 3 over 2, can you see how you would then, this is a term, and within the term you have multiplication, and this can be canceled. So that would lead you to this final answer here. And then the other one is, or the plus as well. You can do that with the plus as well. X is -7/2 plus 2 square root of 3 over 2, cancel. And then you're going to have that as an option as well. So what I'm saying here is it'll also take this as a final answer as long as you do a plus and minus here, or write them in separately. If you ask your calculator, because people have a hard time understanding this as far as number-wise, you can punch in your calculator. This whole piece here, hopefully I have a pen. Okay, so this whole piece can be put in the calculator with just a plus and just a minus. Those are very different decimals, okay? So those aren't exactly the positive and negative of the same thing. You should plug them in your calculator and just check it out so that you get an understanding of what that means, so that you understand plus minus. Unless here in this one, it's going to be exactly plus or minus the same thing, because it was simply an x squared. So play with that a little bit as far as the decimal number. Okay, so x squared plus 49 is 0. Use the square root property to solve. I want to talk about this for a minute. If I had x squared minus 49 equals 0, you've solved these before. You've solved these in chapter 6. You solved these by factoring, and you said, oh, that's a difference of squares. I want to show you this, because this is, if this had been a negative, you see, this is a negative, meaning a difference of squares. You could use that formula. And then you have an x plus 7 is 0 and x minus 7 is 0. So x is 7 or x is -7, you see? You can solve this one by using chapter 6. You can also solve this one by using the square root property. But this is, remember, I'm showing one, excuse me, I'm showing one with a minus, very different than what's on number 4. So if I said to you, hey, solve this using the square root property, then you would say, what do I do? First, I need to isolate the something squared. And then I need to use the square root property, square root plus minus. So it's x is plus or minus the square root of 49, which means x is plus or minus 7. You see, that's the same exact thing as if you factored. The reason the square root property is a good one to know how to solve by is that it works even if not factorable. But I like to tie this stuff back together because it's all related. Meaning, so you can't factor a sum of squares. If you were in my class on ground, I would have yelled and said, I'm going to use a ruler and pop people if they try to do anything with the sum of squares. I said, sum of squares, what do you do with it? You leave it alone, you leave it alone. So then you said, okay, sum of squares is prime, I cannot factor that. But I can solve by using the square root property. So you're going to take your square root, you're going to first isolate the something squared, okay? So you're going to have x squared is negative 49, right? Because you're going to subtract 49 from both sides, and then you take the square root, so then you're going to apply the square root property. And that's what we've done a few times so far already, square root, square root. So x is plus or minus the square root of negative 49. Now you have to be careful. Now you're going to use other things that you've done. X is plus or minus square root of negative. What does that mean? You're going to pull the I out because square root of negative 49 could be written as square root of negative 1, which is I, and the square root of 49 is 7. So then the final answer, x is plus or minus 7i. Okay, so when it's prime and it couldn't be factored, it turned, in this case, into an imaginary number. Okay, so you just got to watch this, little details here. We'll do 2 more, I think, and then we're done with this recording, and then I'll do the completing the square on another one. Okay, use the square root property. So the square root property is if something squared equals k, then that something is plus or minus the square root of k. So first you need to isolate the x squared, right? So, or something squared. Maybe I should have used an a in this case because later there'll be something else. So we have 3x squared is negative 240. And then you need to divide by 3, right? And so that's negative 80. And then you have to use the square root property. And then at the end, we should always check, but I'm not always going to check them all. Unless they start out radical, then I check every single one. So x is plus or minus the square root of negative 80. Then we make our little tree, 2 times 40. There's different ways to do this. So please, or 80, but it has a 16 in it. Well, this is where we debate on what's better, 16 times 5. Isn't that better if I put this, 16 is a 4 squared? Do you see what I'm saying? So the 4 comes out and the 5 stays under. So that would be faster here. We talked about this before, plus or minus the I. So we'll talk about how that's written, but this could be written as a square root of negative 1. And hang on, I'm going to show you as if you've not had that lesson before. That's that, this turns into I, right? And then we have a square root of, and 16 times 5 is 80. And then x equals plus or minus 4i square root of 5 is the best way to show this. Because you're going to pull that 4 out, but we'll put that in front of that I, and then we put the radical at the back. Now you can enter this in as a negative 4i square root of 5, comma, positive, you wouldn't put a plus, but 4i square root of 5. I like putting them with the plus or minus. You can also, let me clean this up. I'm not against it. It's just more dangerous, but you can put plus or minus 4 square root of 5 I. But if you do, make sure that I is outside of that radical. So that's where we prefer this one that's circled here. Okay, one more maybe, hopefully only one more. I'm just trying to make sure we're covered on all the bases. Oh, there's 3 more, so I'm going to pick one of them. I'm not going to do them all. Let's do this one again, because we have to isolate. You see how here's already something squared is, something squared is. So you just immediately go into the square root property. On this one here, you're going to isolate the something squared first. So you're going to have something squared equals a constant. That's your goal, okay? Something squared equals a constant. So this is what you want. This way, I don't want you to always think as x squared. It's something squared. Whatever that something is, it could be a polynomial or whatever. Something squared equals a constant. That's what you want before you use that square root property. And then use the square root property. So you're going to take square root plus minus. So you're going to say x plus 1 is plus or minus square root of -1 square root of 45 is 9 times 5. And then you have x plus 1. It's a little more dangerous, so be careful. Is plus or minus. Now the square root of 9 is going to make a 3. The square root of -1 is going to be an I, and that square root of 5 is going to stay there. And then you don't just have plus minus stuff. You actually now you need to still isolate that x here. So we're going to subtract 1, and this is where you have to be careful. This is where you can split it up and say x, excuse me, x equals, x either equals, you're going to move the 1 over. So you're going to subtract 1, -1 plus or plus 3i square root of 5, or x equals -1 minus 3i square root of 5. Those are 2 answers, so that's or. Either or. Or you can write them as just 1. But be careful, it's not 1 plus minus, it's a -1 plus or minus 3i square root of 5. So those are all the same answer. Okay, so hopefully that helped. And then I will do another recording on the more difficult completing the square. Thank you.